All right, welcome everybody. This is section 5.3, binomial distribution. Here's the criteria for something becoming or being a binomial distribution. First, there's a fixed number of trials. That means they're doing an experiment and they're going to say, we're going to do 10 trials, 10 experiments, or 10 flips of a coin, or 10 pulling out of a card or something. Each trial can only have two outcomes. So you can have flip a coin and have a head or a tail. Roll a dice. It could be even or odd. You can only have two outcomes. You can't have more than two outcomes. Your two outcomes could be rolling a dice. You could roll a 6 or don't roll a 6. So I mean, any other number is don't roll a 6. So in a binomial means two. You can only have two outcomes. Each trial has two outcomes, and each trial is independent. That means each trial is different from the other, and it doesn't. The previous trials don't affect it, and the probability of success must remain the same for each trial. That means the probability is the same throughout the entire experiment or trial, or whatever you want to call it. You can't change probabilities midway between. The rest of these things, I'm not too worried. On our calculator, we know these are something you need to know. N is the number of trials. X is the number of successes of what you're asking. These are the number of trials, but X is the number of desired outcomes, or desired, you can call it a success, like getting 4 heads. That's the desired outcome. What's desired? Let's see what else we have here. And they give, here's the actual formula. We're not going to use it. We're going to use the calculator. So here is 517, example 517, survey of a doctor's visit. A survey found out that 1 out of 5 Americans say he or she has visited a doctor in a given month. So 1 out of 5, that's a fraction. 1 out of 5 visit doctor in a given month. This is the probability. You can write a probability as a fraction. So that's the probability. 1 out of 5 Americans visit a doctor any given month. If 10 people are selected, that's the number of trials. That's N. This is the probability. 1 in 5 go to a doctor. That's the probability. The number of trials is N. Fine. So here is the question, and I'm going to do the question in red. Find the probability that exactly 3 will visit the doctor. So we want to know the probability that exactly 3. Exactly means equals. The probability that exactly 3. And if we look at this box down here, the symbol for exactly equals, we're using binomial PDF. And it's different if it was greater than or less than, but for equals, we use binomial PDF. So that's really important. When you see an equal sign in the problem for binomial, we use something called binomial PDF. And if you look here, this is the number of trials. P is the probability, and X is the number of success, or what we desire. We desire exactly 3 in this case. Do you see exactly 3? And so we're going to use our calculator to do this. and we have to find binomial PDF. So we have to find binomial PDF. If I can remember everything, one bit. I have to write these things down because I forget. As soon as I turn this thing off or the page off, I end up forgetting the numbers. So I am going to just write it down. 1 in 5 is the probability. X equals 3, and there are 10 trials. All right, so I am going to stop sharing and go to my calculator. I'm going to turn it on. And what we want to do is we want to go to a calculator page to do this. So binomial PDF, we want to go to a calculator page to do this. So I'm going to hit I need a new page, control document, new page, add a calculator page number 1. And we're on the calculator page now. And so we need to find binomial PDF. The way to do that is menu. And we'll write this down here in a second. You guys can't see that at all, can you? I can barely see that.
It's pretty clear.
Oh, is it? Okay, good, good. Menu number 5, probability, and then number 5 again. So we're going menu 5 and then 5 again, distribution, probability, then distribution. And if you look, number 1 is normal where we have to look for binomial PDF, and that's down further. If you look there, A is binomial PDF, B is binomial CDF. So we need to do both of these, but not for this problem. Equal sign is PDF, less than or equal is CDF. So we're doing PDF and we hit enter for A. And then it says the number of trials. Well, the number of trials, there were 10 trials. So you guys can see this clearly? Because it's weird is I don't see it that clearly. It's opposite for us, I guess. The number of successes, we want exactly, this is the probability. I'm going to put 1 divided by 5 in the probability, 1 over 5, and 1 divided by 5. And then the number of successes we want is 3. So this does all the work for us. 10 trials, probability is 1 divided by 5 of a success, and then 3. And so now when I hit enter, I hit enter, it gave me an error. I think I hit enter too many times. So let me grab, I have a negative in there. So I'm going to do that one more time. I had a negative somewhere in there. So I'm going to go menu. I'm probably going to have to start over. Menu number 5, and then we got to go down to A. Binomial PDF. Hit enter. There are 10 trials. 1 divided by 5. And then X equals 3. And hit OK. Why is it giving me an error? I'm going to take my calculator and look at it. I ended up with that plus. Oh, we're going to try one more time. Menu 5, A. The number of trials is 10. Probability of success. Maybe I'm going to still hit 1 divided by 5. And the X value is 3. And then I'm just going to hit OK. Okay, finally, it gave me the right answer. I don't know what I was putting. I must have been not hitting enter. I must have been, maybe I hit equals instead of enter. Hit subtract. So did you guys look, when you're doing this, did you get this 10, 1 over 5 and 3? And there's the percentage. That's your probability of getting exactly 3 people going to the doctor. Everybody okay with that? So let me go back to the screen here. And my probability is 0.201. I'm just going to go 3 decimal places. So for this problem, 0.2013. Did I just say something else? Let's see, look at that. 0.201, 0.201. This is the probability of getting exactly 3, and n equals 10. Probability equals 1/5, and x equals 3. 0.201. So that's exactly. And I'm going to write down what we did here. The first thing we did was calculator page. On our calculator, we went to a calculator page. Then we hit 5, 5, and A. Binomial PDF. And this was probability. This was distribution. And then binomial distribution. And we filled in the blanks. We filled in trials was 10. Probability was 1 divided by 5. And then whatever it said next. I'm just going to go see what it says next. 5, 5. A, you can just hit the A button and it says X value, which is the number of successes is 3. So that's what we did on our calculator, and we got 0.201. So these are the things we typed in our calculator. Everybody okay with that? I'm hoping you tried that out and you're just not sitting there goofing off. All right, so we're going to move on because we actually have quite a bit to do. There's all kinds of different ways of doing these binomial PDFs. So binomial PDF is when we have equal sign. And once again, I have the video in module 10, but you can click on this link if you're using the electronic version of the workbook. And it'll take you to the video and show you how to do that also. So once again, here are the steps. I have the steps written down right here. Go to the scratch page or to a new calculator page. Number 5 probability, number 5 distribution. A is if you have an equal sign. But we got to go to B if it's X is less than or equal to, okay? So B if X is less than or equal to. So this looks like an easy section, but it's really a hard section. And this QR code is the same thing as it's for that video of doing this, the video that you have in module 10 right now. All right, so let's do this problem here. It says a survey on employment found that 30% of teenagers consumers receive their spending money from part-time jobs. So the probability that your teenager spending money, I'm just going to put spend money, is 30%. If 5 teenagers are selected at random, that means n equals 5. That's the number of trials. Find the probability at least 3 of them will have part-time jobs. Now, I don't want to do this problem. So even though we're talking about this problem right now, this is a harder problem. So I'm going to skip this and we're going to come back to it. we're going to actually come back to this one. That's like a little bit harder. And we're going to do this down here. And I'm going to write out, we're going to do each one of these. We're going to do each one of these problems. And it's all going to have the same scenario. Teacher, and I think this might be similar to what I did on the video. Teacher gives test 10 questions. The questions are true or false. Remember, binomial, you can only have two answers, true or false, one or two, A or B. So binomial, you can only have two possible answers. Teacher gives 10 questions, test that's true or false. And the first question is, and this one here, the probability that the student gets 7 questions correct. And we're talking about exactly 7. You can't get 8, 9, or 10 correct. A student gets exactly 7 questions correct. Exactly, once again, is an equal sign. Equals, we use PDF. Do you see? Everybody else is not equals, use CDF. So for PDF, for equals, we use the PDF. So on my calculator, 10 questions, true or false. By the way, what's the probability of getting a question correct? What's the probability of getting a question correct on a true or false test? Anybody? What's the probability?
50-50.
Yeah, 50%. Yeah, it's binomial distribution, 50-50. It's 50% of getting it correct, 50% of getting it incorrect. So, you know, if they said 73% to get it correct, then it would be 27 getting it incorrect. It has to add up to 100%, but there's only 2 answers possible. So 50% getting it correct. In this problem, n equals 10, there are 10 questions. N equals 10, the probability is 50%, and x equals 7, because we want to talk about exactly 7 correct. So I'm going to go ahead and do that on my calculator really quick. Turn it on. I'm on the calculator page. I'm going to go to menu, 5, 5, and then A. And I'm just going to push the A button on my calculator. And the number of trials, there were 10 question test. Probability of success was 50%. I'm just going to put 50% is 0.50. And the number correct we want is exactly 7. And there is the answer. Probability of getting exactly 7 correct. And every time I leave, unfortunately, everything gets erased here. For exactly 7, the answer is 0.117. If I round it to 3 decimal places, we might want to do, I don't know what they want they might want 4 decimal places. You'll see when in the homework what they want. I'm going to do 3 decimal places for now. That's 3 decimal places. All right, so the next one. It's the same question. There are 10 questions, 10 question test. They're true or false. And what's the probability of getting at most 7 correct? And I'm going to say at most 7 successes, 7 correct. Well, when you say at most, 7 is the most. The way to write that is 7 is the most you can get correct is this. You see 7, X is less than or equal to 7. At most means you can have 7, that's why the equal sign, or you can have less than 7. You can have 6, you can have 5, you can have 4. The at most you can get correct is 7. So this is what it would look like, the probability that X is less than or equal to 7. And I would write this down. Well, they have it right here, at most. X is less than or equal to 7. So that's at most. So we have to put this in our calculator, and everything is the exact same, except we're going to CDF, B on our calculator. So let's go to the calculator, and we're going to go to menu, number 5 again. And then we're going to go to B. So you can hit B, or I'm going to go to B. And there's B, binomial CDF. Do you see it's not PDF anymore, it's CDF. The number of trials was 10. The probability of a success was 50%, 0.50. And the at most number that we're going to type in is 7. I need to get it to the next one. Wait. They have it different here. So, okay, so the at most is 7. So they have a lower and an upper bound. So if at most is 7, then the smallest amount is 0. You can get 0 correct, but the largest amount is 7. Do you see? You can get between 0 and 7 correct. At most means between 0 and 7. And so when I hit enter, it gives me the probability. When I hit enter, it gives me the probability, and there's the probability. And so now I know I need to explain this a little different, and I'll show you that here in a second. At most, so X is less than or equal to 7. And by the way, you on a test, you can get 0 correct, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 correct. And at most 7 means all of these right here between 0 and 7. At most means between 0 and 7. And when we put this in our calculator, you saw we used CDF this time, and that was B on our calculator. This was A on our calculator. And the probability for this is 0.945. 0.945. So that's at most. All right. The next one, stop me if there's any questions. The next one is probability of fewer than 7. So we're still doing, and if I go 0 correct, 1, 2, 3, I'm going to keep on doing this, 4, 5, 6, 7, 8, 9, or 10 correct. Here it says, what's the probability of getting fewer than 7? See, we're on the third one, fewer than 7. Well, fewer than 7 is 6, 5, 4, 3, 2, 1, or 0. Fewer than 7 doesn't mean 7. At most 7 means 7 is the most, but fewer than 7, you do not include 7. So we're only including these. Fewer than 7 is 0, 1, 2, 3, 4, 5, or 6. So our low number we're going to type in is 0. Our high number for this problem we're going to type in is 6. And we're always, if it's not an equal sign, if it's not exactly, we're always going to use CDF. So fewer than 7 means we type in 0 and 6. Because 6 is fewer than 7 and all those other numbers are fewer than 7. Okay, so we're going to do that on our calculator. Menu, 5, 5. B, I go down to B, which is binomial CDF, 10 trials. Probability of a success on a true or false test is 50%, 0.50. And 0 is going to be there. That's the lowest number. And the highest number, I got to pull this out because I don't know why. There it goes. It went down. And the highest number is 6. Because it said fewer than 7. And now when I hit enter and hit enter again, I get my new answer. 0.828. 0.828. So for fewer than 7, we type in 10 trials, 0.5 for probability. And do you see, instead of 7, we do 7 minus 1, you do 6. They even show you this formula here. You type in 6 because 7 should not be included. If we're saying fewer than 7, you should type in 7 minus 1, which is 6, because 6 is fewer than 7. And when we put that in, I already said we get 0.828. The probability X is fewer than 7, less than 7, but not equal to, is 0.828. All right. Anybody actually trying these on their calculator? I'm hoping you guys are doing this. This test gets really difficult if you don't try it. Yes?
Yes.
Yeah.
Okay, just want to make sure. This is I mean, especially the words, I mean, each one, if you look at this table, it's really important to have this in front of you when you're doing these binomial distributions, because depending on the wording of the problem, depends on how you type this into the calculator. Next is at least 7. So if I say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 correct, what's the probability of getting at least 7 correct? So which numbers do I underline for at least 7? Can somebody tell me? At least 7.
0 through 7.
Well, at least 7, that means 7 is the least.
So starting at 7?
Yes, these are the numbers that count in the probability. At least 7, that means 7 is the least. You know, we already said at most 7, where 7 was the most. But now at least 7, 7 is the least on here. 7, 8, 9, and 10. So when we type this in, it's going to be kind of cool the way we type this in, and I'll show you that in a minute. Our calculator, at least 7, looks like this. X is greater than or equal to 7. That's the same thing as at least 7. But if you look up here, equal sign is PDF, and I mentioned that already. Less than or equal to is CDF. But we don't have one, and do you see even less than is the same thing as CDF, but you have to subtract 1 from the number like we did. But here, X is greater than or equal to 7. So I'm not too worried about this part because we already said, we underlined, if you underline the numbers that we're talking about, you can see the smallest number is 7. That's the smallest. The largest number is 10. So we're going to use CDF we're going to use the CDF with the smallest number 7, smallest number 7 and largest number 10. Because you got to know which ones you're going to be using. So 7 through 10. So when I go back go back, if it lets me, to the calculator. We're going to go to menu, 5, 5, and then B. Binomial CDF. There are 10 trials. Probability of each question being correct is 50%, 0.50. The lower bound this time, the smallest number that counts is 7. The largest number that counts is 10. You see, we're going to count all the probabilities of everything from 7 to 10. And then when I hit equals or enter, I get my answer. 0.172. If I round it to 3 decimal places, it'd be 0.172. Which is cool because we don't have to do the 1 minus. And I think in the video, I thought I canceled this out where we don't have to do the at least 7. And my answer was 0.172. 0.172. Probability of at least 7. That means we counted 7, 8, 9, and 10. This was the lower boundary. And this was the upper boundary. And this is what our probability is. All right. Now they talk about this 1 minus. That's if we use the other calculator. Well, you can actually do 1 minus. By the way, you can actually watch. Let's try this. You can actually do 1 minus the binomial where we have 10.5. And then if we're doing 7, 1 like less than 7 is 6, right? X minus 1 is 6. So let's try this on our calculator, 10.5 and 6, but we're gonna do 1 minus this binomial PDF. Watch how I do this. We should get the same number. We're gonna do 1 minus that. So on my calculator, I'm gonna start off with 1 minus, and a subtraction sign, 1 minus, and then I go to menu, number 5, number 5. B, sorry, I gotta hit B, there we go, B, 10 trials. Next answer is 0.5. And then the lower boundary will be from 0 to 6. You see, we're doing the lower boundary from 0 to 6 because 7 minus 1 is 6. And now when I hit enter and enter, do you see how I get the same answer? I get the same answer. So you could do it 2 ways. I say, don't worry about that 1 minus. Don't worry about that 1 minus. This problem here, X is greater than or equal to 7, and greater than or equal to 7, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7 is a lower, 10 is the upper. Now, if you do it 1 minus, you have to do, and I'm going to do the 1 minus in red, but I don't recommend it. 1 minus, and then you're going to do PDF or CDF lower 0 to 6. See, they want you to find this probability and do 1 minus this probability, which equals this probability over here. That's how the old calculator did it. Our new calculator will always let us pick the lower one and then the upper one, and then we're good to go. We don't have to do the 1 minus, which is kind of cool, I think. All right, we have one more probability. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Probability that x is greater than 7. If x is greater than 7, I underline greater than 7 is 8, 9, and 10. Do you see? It doesn't say equal to 7, it says greater than 7. So we're only doing these numbers. My lower bound is going to be 8, and my upper bound is going to be 10. So we're going to do the same thing with the CDF, but we're going to use 8 as the lower bound and 10 as the upper. And they talk about the 1 minus again, but we're not doing the 1 minus. We're just doing the upper and the lower. X is greater than 7. These are all the numbers that are greater than 7. The lowest one is 8. The highest one is 10. So if I go on my calculator, menu, 5, 5B. Oh, I hit something wrong. Menu, 5, 5B. Okay, I'm here now. Number of trials is 10. Number of success is 0.5. The lower bound, we said greater than 7 is 8 is the lower number, and 10 is the larger number. Hit OK. And there's our probability. So when I do that probability, I get 0.05 if I round it to 3 decimal places. 0.0, let's say 0.055. This is the probability that x is greater than 7. And we had to type in an 8 in the lower and 10 in the upper. Right, greater than 8. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, greater than 7 are these 3 numbers. All right, so that's binomial distribution and being able to do each one of these. And each question that you will end up with will be some kind of situation there. It'll be something similar to these words that they use here. Just don't be confused about these 1 minuses. Don't use the 1 minuses, write it out. And so you know what the smallest number and then what the lower number and what the upper number will be. All right, in the binomial distribution now, they show you, hey, you can, back in the olden days, we used these tables and it was a pain in the butt. We're not going to be using these tables, and this shows you how to use the tables. We're not going to be doing that. But this is what you need to write down. I guarantee half of you will miss this question on the test. That's why I'm saying put a big star on this page. Binomial distribution and mean, variance, and standard deviation. Because they're going to say, find the mean for this problem, and it's a binomial problem. And you're going to try to do it the other way that we've learned it in the past. And that's going to be wrong. This is how you find the mean for binomial distribution. So the symbol for mean is this right here. That's the average. Mean is the average. That's population average. It's the number of trials times the probability. So mean, and here's the symbol for mean, is n times p, the number of trials times the probability. Variance, do you see, here's the variance, is the number of trials. Oh, this is good. the number of trials, we already know P is the probability, Q is the opposite probability. You know, you only have two. If probability is 50%, then opposite probability is 50%. It has to add up to 100. If the probability was 70%, then the opposite probability is 30%. Do you see? Probability of getting it right is 70. Probability of getting it wrong would be 30. It has to add up to 100. The P and the Q have to add up to 100. So P is the probability, Q is the opposite probability, the number that makes it add up to 100. And then standard deviation, to get rid of the square, you take the square root, and it's the square root of NPQ. Once again, N is the number of trials, P is the probability, and Q is the opposite probability. So you have to put a star by these in your workbook. More than half of you, even though I've just mentioned this, more than half of you will get this question wrong on a test because you don't have a star next to this. This is the mean, variance, and standard deviation for binomial distribution.
Professor, I have a question.
Yes.
So for the variance and the standard deviation, the trials, the probability, and the opposite probability are still being multiplied together?
Yes. Yes. And we're going to do that right now. Yes. Yes, they are. NPQ means they're all being multiplied. Yes. If there's nothing between two letters, it means there's an invisible multiply sign there. Thank you for mentioning that. Yeah, it means there's an invisible multiply sign between them. So here in this problem here, it says MetLife Insurance reported 2% of all American births result in twins. 2% are twins. If a random sample of 8,000 births, that's our N. That's the experiment. We're experimenting. We're doing a trial with 8,000 people giving birth. Find the mean, variance, and standard deviation. So first of all, the mean was, what was the mean? N times P. So the number of trials is 8,000. The probability, find the mean, variance, deviation of the number of births that would result in twins. The probability of getting a twin is 2%. And the way to write that in decimal form is 0.02. You could actually put 2% and then put the percent symbol here if you want, but the decimal equivalent of 2% is 0.02. So we just put this on our calculator. You know, go to your calculator page and just hit 8,000 times 0.02. I'm already on my calculator page. 8,000 times 0.02, and out of 8,000 births, 160 result in twins. Mean, the symbol for mean is that U symbol. So the first answer was 160. Now we're going to do variance. Variance is NPQ. So N, once again, is 8,000. P, the probability of getting a twin, is 0.02. Can somebody tell me what Q is?
Would it be 0.98?
No, 98%.
Yeah, 0.98. They have to add up to 100%. If P is 0.02, you do 100 or put 1 minus 0.02 and you get 0.98. So this is the variance. This is the variance. So we're going to just put that in our calculator. 8,000 times 0.02 times 0.98. And our variance I got is 156.8. So you could say our variance is 156.8. That's the second part of the answer. Now, standard deviation is taking the square root of 8,000 times 0.02 times 0.98. Or you could just take the square root of this. You get the same answer since that was already there. But let's do that on a calculator. So let's take a look. On my calculator, find the square root symbol, which is right above the x square. So you have to hit Control x squared to get to the square root. 8,000 times 0.02 times 0.98. We have everything in the calculator. You hit enter and you get an answer. So for the standard deviation, and that's what we're doing, standard deviation. We did this 8,000 times 0.02 times 0.98. And I get 12.522. 12.522. And if we do the square root of 156.8, let's do the square root of 156.8. We should get the same answer. You know, we had the answer there. Let's do square root of 156.8. And you see, we got the same answer because this, when we multiplied all that, that was the variance, and we got 156.8. But when you take the square root, you get 12.55. So you could have used the answer before and just took the square root of that. And that is 5.3. I do want to go to the homework and take a look at a couple of the homework questions. So let me go to the homework really quick.
Professor, I have a question.
Yes.
Are we gonna do the question that we skipped?
Oh, yes, let's go back up. Thank you. See, we can do that one now. So it says a survey, 30% of the teenagers spend money at the job. 5 teenagers are selected at random, N is 5. Probability is 30% spend their part-time job money on junk or whatever they say. Find the probability of at least 3. At least 3. So there's 5. You can get 0 people, 1, 2, 3, 4, or 5. At least 3 means these 3 people, correct? At least 3 means 3 is the least, 4 or 5. So our lower boundary would be 3 and our upper boundary would be 5. So do you see how I write these down? When the N is 5, I write them all down. 0, you can get 0 students that spend money, 1, 2, 3, 4, or 5, since we're talking about 5. And at least 3 means 3 is the least, 3, 4, or 5. So our lower is going to be 3, our upper is going to be 5, N is 5, and P is 30. So I go to my calculator and I go menu, 5, 5, and then B. Since it's not equals, A is for only equals. We do B, binomial CDF. The number of trials is 5. probability of success is 30%, 0.30. Lower boundary is 3, and the upper boundary is 5. So let me just show you. The thing is, as soon as I go away from that, everything gets erased. So I went to binomial CDF, menu 5.5B, 5 trials, 30%. Lower was 3, the upper was 5. And now if I hit OK and hit enter, it gives me the probability. Yeah, once we went through all of them, we should easily be able to do the, these problems that they talk about. So I'm going to write this down if it lets me. And so this answer is 0.163. And once again, 1, 2, 3, 4, 5, at least 3. And that's the key. The words at least 3, 3, 4, or 5. That was our lower, and that was our upper. And this is what you should get. N equals 5, the number of trials. P equals 0.30. Or you could hit 30%. There's got to be a percent symbol on here somewhere. I just don't know where. I'm sure it's in there, probably on the menu or something. I don't know where the percent. Oh, it's probably on numbers. I don't know. Action. There's got to be a percent symbol in here somewhere, or you just change everything to decimal equivalent. All right, so we answered that question. Let's go to do a couple of problems in the homework. What did we just do? 5-3. So here it says compute the probability of X successes, 0 successes, and you see it's an equal sign. They give you probability in N, so we just go to our calculator. N is 15, probability is 0.2, the number of successes is 0, and it's equal sign. So we go to our calculator. Equal sign is A. Remember, you go to menu, 5, but we go to A because A is equals. All the rest are less than or equal to. The number of trials we said was 15. The probability of success, I have no idea what I just said. So I'm going to go back. Probability was 0.2, 15, 0.2, and 0. Oh, I could have probably just, I could have went 15. Probability is 0.2. Oh, I did the wrong thing there. Sorry. Menu. It's so hard for me to do this from the way it's angled. A. Trials is 15. P is 0.2. And the X value we said was 0. The number of successes is 0. Go to enter. And my answer is right here. let's go to see if we type it in. Does it say how many decimal places? Uh-oh. It doesn't say how many decimal places. I'm going to show an example. I think they're probably going to do 4. I'm going to see what they're using in the example before I type one in. Oh, they're going 3 because the table says 3. They're actually showing you in the example how to use the table. You can use the table if you want. I don't recommend it. So we're going to do 3 decimal places, and 3 decimal places is 0.035. My calculator says 0.035. That's 3 decimal places. And I'm just going to check I'm just going to check the answers because I'm only going to do 1. I don't want to fill it in. Or it's not going to give me the answer. Check my answers. Come on. Oh, okay. So the first one looks like it was it marked correct? Yeah. They didn't mark it wrong, so it must be correct. Okay, so that's what you do for an equal sign. So I'm going to go to more questions. There's another equals, that's A. Remember, that's A on the calculator. At least 8 out of 12 correctly. So at least 8. So let's do this one. So here we're going to find the probability of guessing 8 out of 12. So there's 12 total. So if I write this down, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, at least 8. 8 is the least. So we're talking about these numbers. 8 is my lower. And I really recommend 12 is my upper. I really recommend writing it out like I do. It's gonna help you. At least 8. Okay, 8 is the least. That's the lower. 12 is the upper. So when we put this in our N is 12, there are 12 questions. A student takes a 12-question multiple choice exam with 4 choices. So what's if you have 4 choices, if question 1 looks like this, here's the answer to A, B, C, or D, 4 choices. What's the probability of getting 1 question correct? If I just pick A, B, C, or D, what's my probability of getting something correct?
1 in 4.
Yes. So my probability is 1 in 4, or you could say 25%. My probability is 1 question is correct out of the 4. So N is 12, probability is 1/4. My lower bound will be 8, and my upper bound will be 12. So this is what I'm typing into the calculator for menu 55B, because it doesn't say equals, it says, this is at least. So that's what we're going to put in our calculator. We're going to put in, I'm going to turn it on. I'm going to go to menu 55B, which is binomial CDF. Number of trials is 12. Probability is 1 divided by 4. Lower is 8, upper is 12, and I hit enter. And I get a very small number, 3 decimal places. .0027. But if you round it to 3 decimal places, that's 0.003. So let's see how that worked out. And we got it correct. So if you go 3 decimal places, you got to go to 4 to see if you round it up or not. 5 or more, you add 1 to that 3rd decimal place. If you had 4 or less, you don't do anything to that third decimal place. So would this be considered likely or unlikely? The probability of getting it correct is 0.003. It's extremely small that the event is likely, right? That's a very small percentage. I think that's what they want us to type in. Let's see. No, I got it wrong. The probability extremely small, so the event is unlikely. Oh, I said likely. I meant to click unlikely. I said it's very small, so the event is unlikely because the percentage is so small. I just typed in the wrong thing there. All right, let's check. Everybody okay with this? This one? It's all depends on the wording, and you have to go back if you need to go back to that one table that we looked at for all the different wordings. Let's see what number 4 says. Find the probability. Oh, all 15 stay in school. Oh, now, can somebody tell me what this means? We know n equals 15 here. Probability. Oh, this is a really good question. Approximately 10.5% of American high school students drop out of high school before graduation. Choose 15 students entering high school at random. Find the probability. Find the probability that all 15 stay in school. And so this is kind of important. What probability do I put here?
$10.5.
Well, you would think so because they wrote this, but this is 10.5 drop out. So if you take 100% minus 10.5, you get 89.5 graduate. These are 10.5 is the dropouts. 89.5 are the people who graduate. Do you see the opposite percentage in this case?
Yes, sir.
Yeah, so it's really important to read these very carefully. They don't always give you all the information you want. You have to find it. So 15 students, that's the number of trials, 10.5 drop out, but we want to know all 15 graduate. This is the probability for a success graduating. And then we need to do X. Is it X equals, X is greater than, X is less than, X is greater than or equal, X is, which one of these is it? A, B, C, D, E. All 15 stay in school.
Would it be E? Is it greater than or equal?
Well, no, because they're not asking if all 15. So that means they want everybody. All 15 is equals. You have to read this and understand exactly what they're trying to say. They're saying 15 people graduated, exactly 15, all of them, all 15. We don't care about if we did greater than or less than, we would say 0 graduated, 1, 2, 3, all the way up to 15. Any of these numbers could graduate. But the question says all 15, only 15, not the 14, not the 13, only the 15, all 15 graduate. So we have to use equals, which is A, 55A. The equal sign is 55A. So I'm going to put that in my calculator. These might be harder than some of you think.
Okay.
Because, yeah.
I'm sorry to interrupt you, sir. So had it said at least, that's when we would use the equal or greater than?
Yes.
Okay, tracking.
Yes. And this says, all 15 is the same thing, exactly 15. Sometimes the wording is different than it's up there. So all 15 is equal. So we hit menu, 5, 5, and then A, because anytime you have equals, you have to use the A. And the number of trials is 15. The probability of success is 0.895. You know, 89.5 is 0.895 in decimal form. And then X value is all 15. The number of trials is 15 and the X value is 15. And when I hit enter and enter, I get my answer to 3 decimal places. I get 0.189 and then 3, so it doesn't change. So this should be the answer, hopefully. Yes, it is. So the question once again, here's the next one, at least. So let's do this next one. Because here's one that says, the first one said all. The next one says at least 13. So once again, we go 0, 1, 2, 3, 13, 14, 15. At least 13 means 13, 14, or 15. 13 is the least. Do you see? At least 13. 13 is the least. So it doesn't say equals, so this is going to be our lower, and this is going to be our upper. We're going to do the same thing. N equals 15. Probability equals 0.895. But then we have the lower and the upper. Lower is 13. Upper is 15. So we have to put this in our calculator. Menu 55B. And 15 is N. Success is 0.895. The lower boundary, type in 13. The upper boundary, type in 15. Hit OK. And we should get 0.796. I get 0.796. And we got it correct. All right, so I want to do one more. I want to do this last one here. Any questions on that one before I erase this? This is what we typed in, and it's menu 55B because it's not equals. I think the key is being able to write down which ones we're talking about on the little thing here, especially on the next problem too. I mean, and it's really important to be able to write this down. Once again, there's 15, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And it says no more than 3 drop out. Which numbers do I underline for no more than 3?
Would it be 0 through 3?
Yes, because we can't pick any number more than 3. No number more than 3 can be picked. No number more than 3. These are all the numbers more than 3. We can't count them. No more than 3. So no number more than 3. So we're going to do the same thing. The N is 15. Probability of success is 0.895. The lower boundary is 0. The upper boundary is 3. There's the lower boundary we're going to talk about. And there's the upper boundary we're talking about, 0 and 3. And we put this in our calculator. Menu 55B. Number of trials is 15. Success is 0.895. Lower boundary is 0. And the upper boundary is 3. Oh. Let me show you what I got on my calculator. I hope you guys are doing this on your calculator. I got 6.01931 E minus 10. Did anybody try this on a calculator and get the same thing I got?
Yes, sir. I got the same thing.
Okay, just want to make sure somebody's following me. I wish I could be at your house right now and see how many of you are actually using your calculator. So this is in scientific notation. This means 6.01931 times 10 to the negative 10. It's scientific notation. That means a negative number here in scientific notation means this number gets smaller, and it gets smaller by a factor of 10. Watch what I do. By a 10 decimal places, 10.01931. You have to move that. You have to put some decimals here. You have to put some zeros here, sorry. And move the decimal 10 places. A negative means this number is going to get smaller. Right now, the number is 6. Now it's smaller if I put the decimal here, but I have to move the decimal 10 times. This number says move it 10 times smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my answer is 0.000000000600193. I had to move my decimal place 2 times. So rounding it to 3 decimal places, the answer should just be 0 because there's no numbers there. Let's see if we get that one correct. Oh, we didn't get it correct. Unless I typed in something wrong on my calculator. No more than 3. Oh, wait. Why? I'm going to erase everything. Can somebody tell me why I'm going to erase everything? I'm going to go ahead and erase. Wait, I'm going to do this. I'm going to do this.
Is it because 3 is a guaranteed dropout? And
Yes,
more than
we
3?
used the wrong percentage because we were doing graduate. 0.89 is grad. All these questions were graduate. Now it says no more than 3 drop out. We were doing graduate. So no more than 3. This is still the same. N is 15. The lower is still 0. The upper is still 3, except the probability is dropout. The 10.5%, which is decimal 0.10. This is the dropout percentage. We're talking about dropouts now, not graduates. See, no more than 3 drop out. So we were using the wrong percentage in here. We got to read the question. Look at that. Even I read the question wrong. I thought I was using the same percentage, but the dropout percent is opposite of the graduate percent. So let's put it in with these numbers. Menu 55B, and I got 15. Probability is 0.105. Lower boundary is 0. Upper boundary is 3. Now, when I hit OK, I actually get a number. I get 0.935. So let's type that in. 0.935. We used the wrong percentage the first time. And now we got it correct. So remember, you got to check the probability of a success. Here, the success is a dropout. You know, I mean, it doesn't sound right, but we're talking about dropout, so we have to use that probability. We used the graduate probability the first time we did it. All right, I think that's all I had for the day. I mean, we pretty much covered pretty much. Wait, there might be one more question I want to do. Give me a second. I'm just going to go through this really quick. Maybe 7 or 8. So you can look at the rest. Oh, here. if we look at this, find the mean, variance, and standard deviation. Remember mean, variance, and then standard deviation for population. For the number of heads when 16 coins are tossed, n is 16. Probability of getting a head is 0.5. Head or tail is 50%. And so the mean is n times p. Remember, the mean was n times p. So 16 times 0.5 on my calculator is 8. Next, the variance. Remember, the variance was NPQ. N is 16, P is 0.5, Q is the opposite of 0.5, which is also 0.5. So when I do that, I get 4. Then, if I take that answer and take the square root of 16 times 0.5, you can take the square root of 4, you end up with 2. So they make it all nice and easy with these nice numbers. So those formulas are really important to have in front of you when you're doing this. And we got the answer. So I just wanted to show you one like this. The mean was n times p. Variance was NPQ, and then standard deviation was taking the square root of NPQ. And these are the answers. All right. That's all I had for the day. If you guys have any questions, I'll hang around and answer any questions. You guys have a good weekend, and I'll see you back here next class period, whenever that is. When's our next